Our next speaker from the Department of Medicine is Julie Parsonnet. She was funded by Immunity, Transplant, and Infection Institute. Julie.
Well, it's a pleasure to be here. Thank you all for coming to my talk. I'm going to just talk about physiologic evolution and what we're seeing in children and in adults over time. This is a picture of what an adult would have looked like in about 1960, their habitat. And this is what somebody would look like now in 2010, an adult male. And a couple of things that you note is that this adult male in 50 years has become taller, has become heavier, and has worse haircut. But aside from that, this is a big difference over 50 years of time, and a lot of people, when they look at that, will say, well, this is because we have better nutrition, we have better food, people are eating more, there's just an improved diet. But what has always occurred to us is that the person who is an adult in 1960 is a very different person than the person who's an adult in 2010. The person who's an adult in 1960 actually grew up in the Depression. And they would have been exposed to all of those vaccine-preventable diseases that we no longer see. They would have very likely been exposed to tuberculosis, rheumatic heart disease. They might have had recurrent and chronic diarrhea. And in fact, over those 50 years, all these diseases have largely disappeared from the United States, okay? A lot of infectious diseases. And including things that are incredibly common, like periodontitis, which we've had great progress in. But many of these other infections, Helicobacter, which I work in, a lot of these infections have largely disappeared in the 50 years for an adult, between the 50 years between 1960 and 2010. And I think nobody would doubt that children, even today, who are exposed to all these illnesses are likely to be thin and to be stunted. There's a ton of data from the developing world that children who have chronic and recurrent infections are small. And they remain small throughout their life, and they also have decrease in cognitive abilities as well. So the question we are asking ourselves is the reason that we're seeing obesity and growth and these changes in body habitus, is it less some of the things that we talk about diet, but the fact that people who were comparing ourselves in the 1960s grew up in an environment which was rich in infectious diseases, where people were quite ill in childhood or comparatively ill in childhood. And now we're having children who are raised in environments where they are pretty much excluded from infectious diseases and from recurrent diarrhea and all those things that we used to see in children who would have been adults became adults in the 1960s. So with help from MCHRI and from ITI and from from the NIH and many other groups, we've been actually doing a longitudinal birth cohort study to look at this. And the idea behind our study is to look at all the infectious exposures that children may have had early on in life and see how they lead to their growth and development. And so we recruit babies, we recruit mothers when they're pregnant, and then we follow them with weekly histories of infectious diseases. We do very intensive surveys of the house. We do very intensive surveys of the environment. We do all sorts of microbiome and virome and immunome studies. And our whole idea is to look at how all these things connect, how the microbiome and the virome and the immunome and infectious diseases and the diet and the mother's exposures and the method of birth and all those things connect and influence growth and development. So I'm going to talk, the rest of the talk, I'm going to have two parts to it. One is I'm just going to tell you a few preliminary data from this, some of which support our hypothesis that infectious diseases, even these mild infectious diseases in childhood, may influence growth. And then I'm going to talk a little bit about some of the ways we are trying to think about monitoring that. So this is the first study that I want to show you. So this is all from this birth cohort stork. And on the x-axis is numbers of days of fever this child had over the course of their life. And on the y-axis is their gain in weight. And I want you to focus first on the orange line. On the orange line, you can see that children who had a lot of days of fever gained less weight. Okay, there's a decrease in weight gain if you had a lot of days of fever. And these aren't days of fever we're talking about severe illness. These are colds and upper respiratory infections, usual fevers that you might see in children in the Bay Area. This is all children in the Bay Area. And if you look at that orange line, those children, it would explain 20% of their growth. That is a huge amount of growth explanation based on the number of fevers they have. Now, a little bit of the problem with this is that you also have this blue line. So the difference between the blue and the orange line is the orange line are mothers who had over 12 years of education. And we felt very confident that they were telling us correctly about whether their babies had fevers or not. When we look at the blue line, those are women who have less education, and we weren't as confident that they actually knew whether these babies had fever. So we're still working on analyzing these data to try to piece together why these lines are so different. The blue line, there was no effect of fever, but the orange line there was. But it was a very profound effect in that group, and we had exactly parallel lines if we also looked at things like diarrhea, which also had the same sort of picture. So it is a little bit of some evidence supporting our sense that these infections really do matter. Another part of this study that we did is we had always thought, well, maybe this is because of antimicrobial soaps that we're actually cleaning up these households, and that children don't get infected because there's all these antimicrobial soaps around. So we actually randomized households to antimicrobial soaps and not. So within the stork cohort, there is that randomization. Half the families had triclosan-containing soaps and half did not. And the blue line is the houses that have triclosan-containing soap, and the red line is those that had non-triclosan-containing soaps. And on the y-axis, again, you can see the number of days of illness over a period of time and follow-up. And there is no statistically significant difference. And the blue line looks less to me, looking at eyeballing it, but there's no statistically significant difference. But what we did find is that the babies who had triclosan in their homes actually received much fewer antibiotic courses. Now, when you look at days of illness, you're looking at mainly viral disease in children, but when we actually looked at diagnoses of bacterial disease and receipt of antibiotics, those in the triclosan arm who received antibacterial soaps did not get as much antibiotics. This is a randomized trial, so it seems like a pretty impressive finding to us. We've also been looking at the virome, and we've had the good fortune of working with Steve Luby and others who are working in Bangladesh, and we're able to look at the virome of these babies in our study, comparing them to what you might see in a developing country or what you might have seen in the United States 50 years ago. And in the left three columns are the Bangladeshi children, and on the right three columns you see the Californian children, and they're taken at 3 time points. V1, V2, V3 are 3 time points, all within the first year of life. And there are a couple things that, so those of you who are not used to reading heat maps, I think you can see that there are less bars on the right side where you see the virome of these children. You also see less red. Red means there are a lot of reads, and the children who are in the United States have much lower virome and much lower diversity of their virome than you would see in children in Bangladesh, or probably in the United States, again, 50 years ago. And the things that we're seeing less of here is Anelloviridae, Circoviridae, Picornaviridae, many different species of virus, including the herpes viruses. They're all different here than they are in Bangladesh. And when we then look at the immune response, we're also seeing a huge difference. So on the top here, again, are the kids from Bangladesh, and on the bottom are the kids from the United States. And this is a CyTOF map, so it shows you all the types of cells that you might see in the bloodstream of these children. And again, I'm not an expert at CyTOF. This work was done in collaboration with Mark Davis's lab and with Scott Boyd. But there's something easy to see, which is if you look across time in the top one in Bangladesh, you can see that the cells that are there change. The picture changes, right? There's less blue, and there's changes in some of these colors, and actually that's depletion of of immature cells and the creation of memory cells. And what I'd like to show you is if you look at the American children on the bottom, on the far right, they look at like Bangladeshi children at 18 weeks, okay? And their immune profiles change very, very little over time. They look really naive compared to the Bangladeshi children who are really depleting their immune responses. So what we're seeing in the United States is that we're not seeing a lot of viral contents in their stool, we're not seeing a lot of infectious diseases, and we're not seeing a big immune response that you might have seen. So now I'm going to change directions a little bit and talk about how we might think about looking at this for the long term. And these are all the many ways we take temperatures in children, and you all know that temperatures are really inaccurate most of the time by many of these methods. But one of the things that we've reasoned about is that if you do take temperature, that if you have a lot of infections, you should upregulate your metabolic rate. And some of the reasons we might be seeing differences in weight is because the metabolic rate of this person is revved up by all these infections and all the inflammatory conditions. And so we've been thinking to ourselves, can we use population average temperature to look at the burden of chronic infections over time? And we've done this by looking at 3 databases. One is the Union Army Pension Database, which includes 166,000 people. And then we've been comparing it to NHANES 1 and to the Stanford STRIDE database. And you can see that the years of birth for the Union Army database was 1800 to 1850, the years of birth for NHANES are 1896 to 1953, and then the STRIDE ones are more modern. And we have over 1 million temperatures that we've been able to look at from people who were born between 1800 and 2000, basically. And I'm going to only show you one slide from here, which shows that actually our temperature has declined 0.03 degrees per decade since 1800. And if you look within cohorts, if you're worried about the thermometers that they use, if you look within cohorts using all the same thermometers, you see exactly the same thing. So this is not an effect of the thermometer, this is an effect of time and the year in which you were born. So actually, if you look at the normal temperature now in adults in the United States, it's not 98.6, it's about 97.5, and or 36.4. Somewhere in that range is the normal temperature in adults. And we're about, I think, to start working and looking at that in children as well. But it shows again, and if you look, by the way, at a third world country, there's one country that has some data, Pakistan, their temperature is still 98.6. So what we're speculating is that we are physiologically evolving, and if Michelangelo had to do the David today, this would be the modern version. And we believe that some of this is going to be very strongly related to all this, our ability to suppress our inflammatory state, our loss of these chronic infections. There are some other things that might be involved, like our ambient temperature, global warming, which may also affect metabolic rate. But those are things that we're exploring, and we're very grateful for MCHRI for helping, and ITI for helping us do this work. So thank you very much.
On whether our kids are better off than Bangladeshi kids for not getting viral infections?
I think we are much better off than we were. Our life expectancy has gone up, doubled, right, in that time. So I would never say, don't give your kids vaccines, don't let them have these illnesses, or encourage them to have illnesses. I think there are probably some consequences to it, to the immune system. One of the things that, again, MCHRI has helped us look at is we're very interested in the role of the loss of infection and allergy, as many people are.
I was going to talk about allergy,
and especially in the skin flora. We're very interested in the changes to skin flora by all the bathing that people do now that they didn't do before. So I would not say that infections are that they're good for you or that we should do anything different about it.
I don't know if Sean has a kind of the metabolism and inflammation and how that relates to BMI. There's obviously a connection, but I don't know if you can comment on what you've seen. But is there a connection, or?
So yes, I mean there's a lot of interest in metabolism and underlying metabolism. The fact is, though, that there are feedback loops, right? If your metabolic rate is slow, you won't be as hungry, you won't eat as much. So there's a lot of feedback loops that go along. There are a lot of data that the bigger you are, the bigger an animal is, the slower their metabolic rate. There are also data that the slower the metabolic rate, the longer your lifespan. And those are all things that we're really interested in exploring. But I don't have answers to that. I think one of the really interesting questions, though, is this idea about also living in the thermoneutral zone, something we're also really interested in looking for. One of the big drivers of metabolic rate is being cold. Nobody is ever cold anymore, okay? Because we always live in a temperature space that's always between 65 and 75 degrees, and that's it. We're never hot, we're never cold, both of which drive the metabolism. There's also a lot of interest in that and how it might relate to development of obesity by limiting your metabolic rate as well.
Great. Seeing no further, thank you very much, Julie.